Hey guys, this video is about the electron configuration and the periodic table. Now, the periodic table has 18 groups or columns, and the elements that are within each group have one thing in common. They have a similar outer electron configuration, and we're going to look at that within the groups on the periodic table. Okay, so we have many different sections of the periodic table. We already spoke about your metals, your nonmetals, and the staircase, the metalloids. Now, there's a group of elements called the representative elements. If you look on the periodic table, they are noted as group 1A through 7A. These elements display a wide range of properties, and that is because their outer S and P electron configurations are not completely filled. So, group 1A is found here all the way to the left. Group 2A is here, the green group. Then you have group 3A, 4A, 5A, 6A, 7A. Okay, these are considered the representative elements. Now let's look at some other groups of the elements. Now let's look at the S block elements specifically. There's two groups of S blocks, group 1A and group 2A. Group 1A are called the alkali metals. They have a silver appearance. They're soft. They react strongly with water. And as you go down the group, the reactivity increases. So, for example, sodium and potassium. Sodium is not as reactive as potassium. Potassium is way stronger. And all the elements in group 1A have an electron configuration that ends in S1. So let's take a look. So here is your S1, the purple. And the elements, hydrogen has an S1, lithium has an S1, sodium has an S1, potassium has an S1. They all end in S1. That's why they're all in group 1A. Rubidium, cesium, and francium. All the way down, they have the S1 ending. Now, group 2A, the alkali earth metals. These contain a pair of electrons. They are much harder and denser than alkali metals. So these guys are going to sink in water. When they dissolve, they form a basic or alkaline pH when reacting with water. Normally, swimming water should be a pH of about a 7. If you were to drop an alkaline earth metal, it's going to cause the pH to go up. 8, 9, 10, 11. Their electron configuration all ends in S2. So this is group S2 or 2A. So helium ends in S2, beryllium ends in S2, magnesium ends in S2. All the same outer electron configuration, all the way down to radium. Okay, it's important to note. Now let's look at the P block elements. P block elements include group numbers 3A, okay, to 8A. They are on the right side of the periodic table, and there's quite a few. There's the metalloids, nonmetals, halogens, other or poor metals, and noble gases. There's a group electron configuration. Because there's 6 groups, okay, we have 1 to 6. Okay, this is your general electron configuration. So let's look at the other or poor metals. Okay, these are the elements found directly below the metalloids. Okay, they are the ones below the staircase. They consist of aluminum, gallium, indium, thallium, tin, lead, bismuth, and polonium. Compared to transition metals, which are to the left of the other poor metals, they have lower melting and boiling points. They are much, much softer, and they have a higher electronegativity. Okay, so here are the yellow elements. These are the other or poor metals. Okay, they are below the metalloids. Now, group 7A, halogens. Group 7A are called the halogens. It's my favorite group. It means salt forming. Okay, salt forms a halo when it evaporates. Okay, like if you leave salt, water in a cup, the water evaporates. It's a halo of salt. And it includes these elements right here. F, Cl, Br, I, and At. Straight down group 7A. They form acids. Acids are a huge part of chemistry. Without acids and bases, there'd be no chemistry. Okay, so they're like my favorite to use. There's a lot of experiments in Chem 2 that you get to work with acids. Okay, so right here, this light blue group is the halogens. Okay, from the top you have the strongest all the way down to the weakest. Now, they all have the same outermost electron configuration, S2p5. Now, if we add the 2 and the 5 up, we get 7. That's why it's group 7A. Okay, 2 plus 5 is 7. So here we go. We have bromine, S2p5. Iodine, S2p5. Radon, S2p5. Okay, so group 7A. Now, group 8A, noble gases. They were previously called inert gases. They are very stable, and they do not react with other elements. Okay, the outer S and P sublevels are completely full. Okay, that's where the term noble comes from. A person of nobility has tremendous wealth. Noble gases have all the electrons. They have enough electrons. They are full. Their S and P sublevels are filled. They do not need any extra electron. Now, the group electron configuration for the noble gases is S2p6. So 2 plus 6 is 8. So your noble gases are this black group right here, from the top all the way down to the bottom. So you can see you have the S2p6 all the way down. Now let's look at the D block. They're called the transition elements. They are the B columns on the periodic table, where the representative elements, the taller groups, are the A's. The D blocks are a transition area, okay, between the metal area and the non-metal area. It contains many elements that produce a lot of nice colors. For example, gold, copper, and silver. So a lot of these metals are mixed with oxides to form oil-based paints. Their electron configuration has the outer S sublevel full and is now filling the D sublevel. So here's your D block. Okay. Scandium all the way to zinc and down. Now, the F block. They're also known as the inner transition metals, and there's 2 rows of them. They are located below the main body of the table in 2 horizontal rows. The electron configuration has the outer S sublevel full and is now filling the F sublevel. They are formally called rare earth elements, but this is not true because some are very abundant. The first row are called the lanthanides. The second row are called the actinides. So 4F and 5F. So you can see here's the transition metals. And these right here used to be right here, which made the table a lot wider. They were then removed from the periodic table and placed below the body of the periodic table. Okay, so if you notice on the periodic table, you have this change in the atomic number. There's a few missing, and that's those right here. So this is the F block. You have the 14 of them. LA all the way to YB. And AC all the way over. And that's it. Okay, so just be familiar with the groups of the periodic tables and the main portions of the periodic tables. And also understand that their outermost electron configurations essentially equals their group number. 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. Not necessarily for the transition metals, the Bs. Not the same. Okay? All right, guys, that's it.